Alright. Hi guys, Clayton here. Today I'm going to do a walkthrough on the current state of Pavlov. So here's our user interface. Instructions. Tells you what's going on. Hop chai lai lai. Got some tea here. Thank you very much. You're welcome. Okay. Package dependencies. That is not a complete list of what you'll need in terms of Python packages in order to run this. So you have Python packages and then you have the Autodesk SDK. Let me show you what that looks like. Open a new browser. This PC, local disk, program files, Autodesk, FBX Python SDK. You don't need converter, you don't need Python bindings, you don't need the FBX SDK because that's talking about the C++ one. It's interesting, you should get the C++ one because we're going to be moving in that direction, but not yet. Right now we're in the Python land, and this is everything, and the most interesting thing to us, I think, is samples. So here's a sample file, and it shows you like, hey, here is a, here's a script, and this is how the FBX SDK runs from raw data. And you can change these numbers, and of course they're just showing you like, oh hey, you want to run this loop or whatever. They're doing everything to show you exactly how many times it has to run. So actually writing from nothing isn't that hard using this. You just have to dig through a lot of crap. But they've done it in a non-intuitive way from a programming perspective to show you exactly what needs to be done, which is nice. So export C03 is what a lot of my code is based on. So it's taken from this and I reworked it. And so a lot of that now is inside of this create FBX file. And you'll see similar commands like add child. Now this is a file naming convention that is a relic of the file naming convention found in the FBX SDK. I'm not exactly sure why they use that, but yeah, LData node, LGeometry node, add material, add child, those are specific methods that belong to these objects. There's some things in here that I have, like fences node. Actually, so that's my name, but fences node didn't exist, so I put it kind of in their format. But it becomes an SDK object. So you dump in this SDK manager, which is what manages everything. It needs it to know what to do next. You tell it the name you want, and then it creates a node. And then you can link those nodes together, you can put data inside those nodes, but it's all a tree hierarchy. So that's what the real true back end of what we're driving toward. And in the front end, we can come into main, run it, starts a new instance, boom, and here we are. So I can say, hey, I want to find some files. I'm going to go to select files. Actually, no, I don't want to go to select files, sorry. Select files, what that's going to do, I'm going to be able to select exactly the files I want, like this. Boom, I want those, and I can see this nice preview, and then it'll give me those three. And then if I start to mess with these rules, then it'll apply the rules. You have to touch them first, because at first it'll listen to you. It'll give you exactly what you asked for. And then if you say, hey, I want to pay attention to these rules, wake up, it'll wake up and it'll start cutting. So right now, like if I get rid of the word forward, there she is. If I get rid of all these, boom, there they are. But what is peaks? Peak. It's going to show me. Oh, hey, I remember taking this data. Hey, I don't care about this data. This data is not what I'm interested in right now. Oh, what's forward? Peak selected file. Okay, time versus force. That is what I'm interested in. Okay, let's get rid of peaks and let's keep side and forward. Great. I want to look at, let's see, what is this? Time versus force for both those files. I want these grouped by the genetic variety name and by the name of the plot of wheat they came from. Tier 1, Tier 2. I want to get it in this style. A line graph. This is binned gradient per assigned vector. So here, right here, default, use height column. It's going to use the force vector, and that's the assigned vector, and it's going to put a color gradient. So the taller something is, the color will change as well. But that can be independent. So right here, it's redundant. It defaults